Okay. Okay, so basically, to teach or understand system design in 1 hour is not possible. It's impossible. So this is just like a basic idea. Further, then you can go deeper into that and dig deeper and learn things. So let's start. So let's have an imaginary scenario where there's a person who wants to build a website which can record the books you have read. So there is a website called Goodreads, which allows you to add a book, and you can say like you're on the like 20th page or 30th page, and if you have finished the books, how many books you have finished, how many books you're currently reading, those can be tracked. So site is actually slow, but yeah, so that's the idea, so that's the application. So what would happen is, so this is not how you should build. I'm just taking you through that whole scenario. So when there's a requirement for such an application, usually what people do is that there is three things. Okay, so first is a requirement. What is requirement? User should be able to log in. User should be able to add book. User should be able to update reading status. So this is the application. So usually what people do or used to do is that they will say this is a front end. Okay, so we have a front end. Again, this could be React or Angular or any of the technologies. So this could usually it will be React. Most people are building in React. So this will be a front end application. Then there will be server. Okay, so this will be the server, and this can be again, so mean stack MongoDB. M stands for MongoDB, and so there is a stack called mean, which is very popular. So basically this stands for MongoDB, then Express, A for Angular. Again, A could be swapped for React or Vue. Then it is Node.js. So mean stack. So usually backend will be Express. So this could be Express, and then there will be database. So usually people go with Postgres in many scenarios, or SQL, but Postgres, when in the NoSQL place, it's mostly Postgres that is preferred by people. So we can have a Postgres database. So this is how usually people think about when building an application. Okay, so then the front end talks to the server talks to the database, and so basically if a user logged in, okay, so even with how that login system works, again, so every part of a web application, every single part like profile page, the user login, now all these require like deep dive of system design to you know discover how it could be implemented. Like this is not straightforward, like it's not like we are thinking like, okay, we will do this way that way in an instant. It's about discussions happens usually, and you have to go deeper into things. So let's say user login. So how here we can handle, usually what we do is that there is something called bcrypt, which which is a library, not just library, which can npm package, which can hash the password. So we hash the password and we store the password hash in the database. So there is a users table, and here you will have the username, then the email, and this password. And password again won't be plain text. So this is again, even big companies have did the mistake of storing in plain text. Facebook a few years back had this issue where their this password stored in plain text got leaked. So that password hashing happens, we can do with decrypt, and the hashed password will live here. When a user enters the password, this bcrypt package has a functionality where you can compare the password user entered and what is in our database. So that reverse decryption can't be done. It can only be compared by hashing it again. So that's how that is done. And so then there will be books table. Okay, so here it will be book id, then book title, then we can have a book cover image, then we can have book author. So again, like you don't have to prefix this book and all. It will be title, it will be uid, and it will be cover image. So this will be here. Then there will be another table called read status. So here we will have the user id, then the book id, maybe like a page number could be here, so that we can understand which page they are on. So Goodreads would have downloaded. Yeah, so this is how, this is the application you're talking about. So here you can see I'm the status of the book currently reading, and this roughly something like this, book number. So again we can have a status to the book, like is it finished or not, but that you can store here because this is just book table. You'll have some other relational table to handle that. So imagine if user logged in and they want to get all the books, then again front end will send to server, server will send to database, and database will send back to the server, server will send back to the client. So this is how it works. Okay, and you build the application, you deploy it to DigitalOcean, GCP, wherever. Usually think in terms of DigitalOcean, or like you bought a VPS and you're doing that. So now imagine like this has a, the number of the RAM and all the SSD and everything is very limited. Okay, so in case of that your site got very popular and it went beyond the threshold of the capacity the your server 4 GB RAM or a 500 SSD can handle. So there you have, then what would you do? Your site became too successful, there are many people coming, and your database is crashing every time, your server is crashing, right? Front end is working, it will work fine most of the time, but yeah, so this will crash, this will crash. So what happens, what you can do? So there is, you have two options. One is called vertical scaling. So with vertical scaling, what you're doing is that, so your this VPS or your server rack is basically having like 4 GB RAM and 500 or 250 SSD. Okay, so with vertical scaling, what you can do is that you can get a, maybe like a, if it's your server, you have the server rack, then you could buy a RAM of like 16 GB and replace the 4 GB with the 16 GB RAM, right? You can increase, you can do some backend, backup, download, and push the data to a new SSD or whatever. You can, they can do that, and you can have a 1000 GB SSD or 1 TB SSD. So this is vertical scaling. The problem with vertical scaling is that, you can't, first of all it's expensive, you are changing your hardware, right? Even you have to buy a new hardware every time, and that's there in both cases. But here you're, you know like this is not, beyond a point it's not possible, right? So that's a limitation of vertical scaling. You can't, like, there is a limitation, like maybe maximum there is 64 GB RAM, or that limitation is there, and it's very costly, because as this RAM and all this space increases, the equipments get too expensive. So that is vertical scaling. Again, with some scenarios you can do that, like maybe I think Stack Overflow and all, when they started they were doing that, like they were just stacking up more server racks, more server rack, and getting like huge RAM and everything. But this has a limitation. So then there we have horizontal scaling. So this we said, this is like 16, we are increasing from like from 4 GB 4 GB RAM to 250 GB SSD. We went to this. We brought new equipment. Okay. So this is vertical scaling. In horizontal scaling, what you can do is that you have 4 GB 250 SSD this server rack with you. What you can now do is that you can say, okay, I will buy another same 4 GB 250. I will buy one more. So you brought that. This will be much cheaper compared to going from 4 GB to 16 GB RAM. So you will buy one more second rack of server. Okay. So you can, I think there is server. Okay, so you can have separate server. And so now that horizontal scale, so this is horizontal. Any doubt with vertical scaling and horizontal scaling, or any other doubts? Any doubts? No doubts? Okay, so okay, good. Okay, so with horizontal scaling, then it's about what we can do is we can uh, then so we brought in new equipment. Okay, so site got popular, everything is crashing. We are like, okay, let's go buy one more 4 GB 250 GB SSD wala server, because this is too expensive, we don't have that much money. So we went and brought another thing. So now what we have, so we have two missions. Then the question is like, what will happen? So our idea is that we will replicate. We will say, okay, database is here in this server, one can handle it, so let's put it in another this thing. So again, so then the architecture will look like something like so there will be a front end. So here you can think like you brought it for one for you brought two 4 GB RAM thing, because one for the database, one for the server. So now things will look like, basically there is a server here, Node.js Express server. Then you have Postgres running here. Then you have same Postgres one more happening here. Then server again, you can have one more happening here. So now you have this, but again, like, how will the front end decide to which we have to? So basically we are doing load balancing. We are saying, okay, one server can handle it, let's split the traffic. And again, with that particular part, just in the area of splitting the how to split this traffic, splitting the traffic, just in this area you can do PhD, right? That kind of, that's how the whole system design is too vast. Like, even just this single part you can do PhD in that much depth of knowledge and options. Many scientific papers are written, many things are there. But for our simplicity, we can say what we can do is, sir, we can put a load balancer here, or reverse proxy you can use. Again, with load, when I say load balancer, then again you can learn there is layer 7 and layer 4, I think. Load balancers are there, so there is too much you can go. So here we can say we have a load balancer. So this is again another service running. So the front end will hit to the load balancer, and the load balancer will choose the, like, which server to hit, right? Again, there is very round robin, and many such algorithms are there that can happen, maybe like random selection, or based on IP address. They do, like, if the IP address is ending in some, like, if the UID of the user coming from the front end is in odd number, if it's odd it can go here, if it's even then it can go here. So basically load balancer will check for the UID. If it's odd, then go to the, if it's even, then it's the number ending, the UID number ending in odd or even, it will do this. This is one example. Again, there are many complex examples and things that goes behind this. So now what happened, there are 2 lakh people coming, but because our system, we can consider, okay, maybe 1 lakh or 1,20,000 is going to this server, and 1,50,000 something, or 1 lakh is going to this server. So now this server is not having much of the load, and this server is not having much of the load. it is pretty much balanced. But so with server, one thing is that it is server is stateless, right? The server doesn't have any state, so it doesn't have to keep any state of when we design a server doesn't care of any sessions or anything. Most of the time it's just whatever you ask it will give you. That's why we have headers and params, all those things. So all those information you pass with that, right? Even when you are building when the authentication part. So here with authentication, again, if I go deep it's too much. So yeah, so basically what the server does is it creates a session ID, and this will be session ID will be created, and the session ID will be passed to the front end, and every time the front end makes a request in the header, it will have the that session ID or the authorization bearer token. All those will be here. And now the question is like, okay, then how we manage that? For that we will have something like redis here to do that part. So the sessions will be managed in Redis, or we can manage it in memory, but then it will crash, it will be gone. But yeah, so usually there will be something like Redis to handle the this session or authentication part there. So every time server gets it, it takes it from here, and it uses. Yeah. So then we are say, okay, we have load balancer here, server is split, everything is good now. But now again, when so in this part, database part, again in that there is a lot of engineering that goes into it. Like do you create the basically what happening, it's crashing because of a lot of read write happening, right? Lots of read is happening, lots of write is happening. So usually with, if it's not, if it's not a social media, the writes will be less, the reads will be more. Okay, so if you know your application is less write intensive and more on read intensive, there are databases which can perform well under that scenario. But if you are like building a social media which will have TikTok or something, and which will have always millions of users there, and they are uploading data constantly, then you could look for a database which can perform better on write. And it's fine, the trade-off is fine with reading. So again, these are talks about seconds, milliseconds kind of optimization. But if we have like large user base, large user, that matters. So with database, again here many paradigms are there, but for now we can simply say, okay, the engineer building this application said that, okay, so this is my master, and this is again master slave, such paradigm is there. Again, all you can say, this one will take all the writing. So all the writes basically, which will happen very rarely, whenever user is like, okay, I want to add a book, that's only happening. So that could be sent to this database. And so again here, then the question is how it will sync. So just in that syncing part, there is a lot of thinking that goes. Again, lots of PhD people working on that part, how the syncing happens, how it should happen, all those part is so there is a process that happens which will sync the data that's written here to the slave database, and this will be used just for reading purpose. So if it's a get request, okay, if the request is get, basically saying I want to read the book, then it will be routed to this. And if it's about, if it's a post method, basically the user is trying to say I want to add this book, or I want to add the page number I am on, then this will go to this database, and the syncing happens behind the scene. Again, there are, so the question is that, so basically I wrote something, but there is a time that taken until this copying part happens to the slave database. So how do you ensure that it happens? So in our case we only have two of this, but with like major applications there will be many instance of Postgres running, right? So how will you ensure that? So again, with that there are some database. So if that consistency of data, okay, again this is like acid principle. So basically acid is atomic, C is consistency, and D is durability, and I is I forgot. I think atom isolation. So there is a principle called acid in the database space, basically atomic. And again, if you go to understand what is acid, then you are again diving into a rabbit hole. There is lots of things. So basically, so like some database focus on consistency, some focus on this isolation part, some focus on this durability and such. So like if you are building an application like a banking system, okay, just imagine you are building a banking system, then the transfer happened. So transfer happened, I transfer 1,000 rupees to a user, that's returned in this database, but Harisa client app is reading from this database, but this change is not yet happened here. So there it's a problem, right? Or maybe I'm trying to send another transaction. So my bank balance was 1,000 rupees. I send that 1,000 rupees, but now my account current balance is zero. But that is not reflected in the read database. So before sending transaction, I will read my database. So that can allow me to send another 1,000. Okay. So that's not acceptable in a banking sector, right? So those parts are taken care by some database are very good for that particular reason. But if you are building a social media, it's fine. So if you are building a social media and you are taking track of the likes, it's fine, right? So imagine a post has like 1,000 likes, but when the user reads, user want to you wrote the you incremented by one and you said okay it's now 1,000 likes. Now the user is coming to read and reading from this database which has now 999 likes. It's fine, it doesn't matter much, like it's not impact, it's like not a huge issue. So you can use that for you can forget about that consistency part. So then so yeah, so what I was saying was there are databases that can ensure like if there is three slave nodes, then that this write when it happened, it's only committed properly when at least out of three at least two copies that, so that database can track if it's copied or not, right? So that's why, so the reason you have so many databases, so many uh, if you like check out the database, there are lots of database. And the reason is that even if you go like SQL section, SQL databases, there are many databases out there. The reason is that because engineers, scientists, all these people, PhD people are working towards all this, they are solving these minor problems, and that's how this happens. So the evolution of like why this Postgres was made, why even like our this Victoria and all users there's a lookup DB, I think. So then from that, based out of that, Facebook created their own version of Rocks DB, which is used by Cockroach DB, I think. So the reason is because everyone is trying to solve one particular problem in this database space and how this thinking will happen, all those things. So again, this is an interesting area if you want to dive into it. So now our application is working now. Front end is hitting the load balancer, and load balancer is hitting the server for writing, and the server is sending to Postgres and doing this. But again, here we are talking about copying the entire database and keeping it. Okay, so this is one way of reducing the load on the server which handles the database. We are saying writes will happen less, so let's put it here. So less is coming. Reads will happen, but reads again here we can do same load balancing kind of thing. We can say okay, for such number of users we can do the reading from here, or for few users we can do the reading from here or and from here. So now because we have three instances running, each will not crash, each can handle the load. And again that to do that again you have to think in terms of how you store that, because now this is replicated, whatever is in here, 10,000 records of data, it is here, it is here, it is here. But there's another method again, how you manage that database from crashing. There's another method of splitting the data. You can say that UID up to 1,000, UID from 1 to 1000 will be. So imagine you're building an application which has the write is too much, then this won't work, right? This can't handle that. Here it is working because it's read intensive, but what if it is write intensive? Then what you can do is that there is something called, so here what you can do is that you can say, okay, UID from 1 to 1000 will be stored here. All the user data related to 1 to 1000 will be stored here, and there will be another instance running. This will be 1000 to 2000. So again, so here again the problem is that server has to keep track of where to fetch the data. Here that problem was not there. You go to any of the instance, you will get the data back. But now the moment you split the data, this is great for scaling. Okay, you can scale it fast because the writes will be fast because the data is not taking much load. So that part is great, but the problem is now the server needs to know where to send the request, right? So now the server is like, okay, earlier it was server was sending just randomly writing here, getting from here, any of this will work. Now the server has to have some sort of state. The server should know what is the UID of the user, and if the UID is 565, which instance to send for the write, right? So here again you will need some kind of system to track that, some algorithm. So again there are algorithms here that can decide where to send, because if you are going to write if you are going to have a Redis database which can track, so you can say this is server DB server 1, and then you have DB server 2. It will be too cumbersome to have another Redis server, and you can do that, but the problem is again latency is happening, right? The every fetch, every interaction that you're doing, there's a latency getting added. The time taken to process one thing is becoming huge. And when we are building solutions, the focus is how that can be brought down. So imagine there is a Redis. So this is a simplest solution. You can have the UID, then you can have the DB server. So there will be records like this. So if it's 565, it will be server 2. So every time if there's a post request that came saying that a finished book, the thing is that it has to know the UID of the user, then it has to fetch the Redis with that, ask which server is it, then Redis will send it back, then okay, done server 2, then it will send, okay, I have to write. So then it will write to the server 2. Okay, so again when you are reading, the same thing happens. You have to know which is imagine now this is same, it has to know from where to fetch the data. So again same scenario, same you have to read from the Redis. Again Redis has to scale as the user increases, so again latency is happening. And yes, so if you see like why we need to do this, because you know databases can hold data. Okay, so then so without this changing partitioning everything, if you think in terms of very simplicity, there's a database can handle records. Imagine there's a million records stored in the database. How you can speed it up? That's a very bare minimum. You'll think, okay, let's have index. You will create index, and index will be able to do it. And again when you think of index, you can think in terms of very simplicity. There is notebooks we have. When school we used to have notebooks, and there was an index page, right? The first page is the index page, and index page has this many lined things where you can put the page number, which chapter you started, all those things. So here you can say 20th page, it's a cell subject on cell biology, something like that. Then page 46, you learned about evolution. So this is your notebook, and you are saying, okay, 20 page, that's cell biology, 46 pages evolution. Okay, now if someone asks, okay, find the page with evolution, I want to read the notes on evolution. If you don't have index, then you have to, from the first page, you have to turn the page, is there evolution? No, turn the page, you have to go through the whole stuff to figure out until you reach 46, then only you will understand. So that will take time because you are swiping through all the page. With index, you can open the first page. That's the only thing you're doing, you're opening the first page. So with other method, it will take 46 page turns, but with index, you open the index page, that's first step. Second step, you see it's 46, so you just turn it to 46 and you get the evolution notes. So this is what index does. Okay, so index, again, you can think of database inside database. So inside database there are tables. So we saw user table, so user, and there are rows here. And again, there are different types of database: row database, columnar database. Everything is used for different use cases. Graph database, vector database, many other. So this will be UID one. So inside database, again, same concept like notebook, there is a pages. There are different pages. So this is, so in database, inside database is stored like this: page 1 UID. Then the same thing is there. You can, so there will be this UID 2, UID 3. This is how the records are stored inside the database. Okay, so then what you can do is that, so this is page 1, there are page 2. So imagine like one page can only hold so much, right? Maybe one page can only hold 3 rows of the database. So then there is 4, 5, like that. So index will be living inside the same database, and index will be, again, it's something called B tree. It's very you can think of it like tree with leaf and nodes. So there is something called B tree. So this is a format in which it is stored. So you can check on that. So then it will say UID 3. UID 3 is in page, or you can say, so I can say UID 6. So UID 6 is in page 2. UID 3 is in page 1. So this is how the index will look. Okay, so this is the index of the database. This is how it looks. So when you say, so most database by default will do the indexing for the UID. You don't have to do that. If you have any extra field like email and such, you can do again indexing for that. So when you're requesting to the database of data of UID 6, okay, and again here you will have many other username, everything is stored here. Username is there, email is there, password is there, everything is here. You say, okay, I want data of UID 6. Without index, it will have to go through page 1, page 2. Imagine our data is living in page 100. It will have to go through all that. Then only, so again, it is memory intensive. It has to collect all the pages first, then you have to go through one by one. Same scenario as the notebook. But with index, it will go to the index, and because this is the B tree system, so again it will look something like one, two, something similar to like this, 4, 5. It's like a tree. So because with this algorithm, this search system, this is very fast search, by the way. This is very faster than other search. So here what it can do is that it will go to index. Okay, UID 6 in page 2, then it will forget page 1, page 3, 4, 6. It will straight away go to page 2, and from page 2 it will take everything in the page 2 to the memory, and there it will look for UID 6, then it got the data, then that's returned, right? So this is how indexing works. But the problem with indexing is again the B-tree has limitation, right? Like there is a number of instances it can trigger. So it will jump, then it will end up with the page. So as the index increases, what the database does. So again, if you see Postgres and such database, they're very intelligently engineered, right? So like it is not guaranteed that you'll go to index. Like often it won't go. There is a calculation mechanism inside the database which will decide which is costlier. Is it much more costlier to go and read from the page which is in the heap memory, here in the heap? Is it straight away go to the page and read, or should I go to the index? So that calculation happens in the database itself. So it won't just default to index. Sometimes it knows that okay, this is what I want. But again, with Postgres and all, you can override that. Sometimes maybe the database calculation is not what you want, or you always want to go to index. It's fine, right? So with Postgres, again, you can understand the time taken. You can see for a query how much what is happening, how is the database deciding where to go, what is the time taken, the steps did by the database. We can see it going through the index, then it going through the page, right? All this you can see inside Postgres and all. Then you can optimize the query, right? So that's why I said, like, it's not just about writing SQL queries, it's about understanding how the database works, how you can optimize the query. That optimization happens only when you understand what is happening behind under the database, right? What is the database doing? So once this index become too huge, right? The index become, imagine there is like, like 10 million records or something, like huge number. Then there will be a point where the database will be like, I don't need index. I could like index. If I go to index, then if I go to the heap, it will take like maybe like 1 minute. But if I directly go through all the pages, it will take like 6 minutes. So less than 1 minute. So let me do that, right? So that will happen. So indexing is not the default solution. Like it will also break if the server is getting queued. That's when you have to think about, okay, what should I do? Should I create a master slave system where one is returned for write, read, or should I again have another instance of Postgres running? But then there are many problems there, like how you will ensure the data consistency, how will you ensure the duplication of writing. So again, so that's where this atomicity and all those isolation things happen. So when we want to update, like imagine I want to basically I transfer some money, I want to update the balance. So every things that happens is called transaction. So with when a transaction is happening, so for a transaction to happen, to write something, first I have to do the reading. So when I read my balance, it will be 1,000 rupees. Then I have to say, okay, transfer it to Haisar. So then I have to update the balance to 0. But what happens? Someone sends another, or what happens if automatically debits some money or something like that happens. So that's where the atomic city and all this, atomicity and other parts have isolation happens. Again, that's very very interesting if you go deeper into that. Like basically, when this transaction is happening, right? Again, this every database does it very differently. There are different options. So before this commit happens, basically this will freeze other transaction happening to this row of the row of, like, maybe my UID is 6 and it has the fields bank balance, all those details. So when I have read this row and I have read it for updating. Okay, so the database, I can tell the database that I am going to update this. That's why I'm reading. Okay, I'm not reading casually. I'm reading because I want to update it. When the moment you do that, the server will the database will lock this row. The database will say, okay, now no one can do anything to this row. So this will be locked. So now if anyone tries to do anything, this won't work. Those rights won't work. Those will only work once this happens. So again, say with, so I send 1,000, then I'm trying to do immediately one more transaction. That won't happen because this has to first finish. So that is taken care by some database very efficiently. Some won't take care of that. So that's where that's where the SQL was NoSQL and those discussions happen. Like SQL can do that better, NoSQL can't do that. All those things. Again, if we come back to our system, we have relation things going on. User reads the book, and there's a status of the book. Also, there is a book cover, right? There you can have a cover. We said cover image. So you can store it here. That blob data you can store. Postgres can do that. But the moment you store the image, the PNG image, it's getting huge. It's getting huge, and you are, again, the space is taken, and the database will become too slow because of the space is taken. So again, there you can think about separating that image into something else. So there you can maybe use NoSQL, or maybe like MongoDB or something like that, or any data does that is like like good to have, which doesn't require calculation, which doesn't require lots of analytics and computation going on. If there is less computation, if you have a data that require less computation, you can go for NoSQL. That will be much better solution. So like, it's about, as engineers, we should not say that I know this language or I know this database, I will only use this. It always has to be open. And if you see, again, if you that's why case studies are very important. Twitter was built on Ruby on Rails, and they changed from that to Node.js. And why they changed? There are reasons that you can read upon. Was Uber changed from I think Postgres to Cassandra. Cassandra is again another database out there. So why they changed, right? So because these companies, again, so another big point is that if Uber changed from Postgres to Cassandra, should we do that? So the question to the answer to that is that, are we operating in the scale of Uber? Right? Uber is operating in a different scale. In that scale, everything will break. Right? A database server, everything will break. All the knowledge that we have of system design and everything will break at that scale. Netflix, same story. Right. So, but we might be having an application with like 2 lakhs users, and we might not need to switch to Cassandra, or we have to do that level of scaling up. But if you are building something like Netflix, Indian version of Netflix, then we have to again think of these things like, where do we store the video files? Again, how we can store that? Maybe we can use S3, Amazon S3, or we can MongoDB GridFS or something like that. And again, all those questions come. Again, this is not over here, right? So when you are thinking about how things could be made better, okay, now we are calling from the database. Now if you see this, in our this case, the book data won't change often. So we can maybe have a cache layer going on here. So there will be a cache layer, and again, you can use Redis for that purpose to cache everything going on here. So here you will cache the database stuff going on. So your server is talking to the cache, and if its data is available there, so book 76 of UID 7 is available here, it won't go to Postgres. So you saved that, it becomes faster for the user. Then, so that's one step. Then you're like, okay, but the front end application is taking too much to load. So again, you can have CDNs, and you can have CDNs going on. You can understand where the user is coming from. If the user is coming from India and your server is in America, and if that speed matters, if you care for the user, you could say, okay, I will deploy the servers, everything, database, everything to India. But if you see, then there are users from US coming, 2 lakh users from US and 2 lakh from India. Then this, why do this, right? So this server is in US, and this server is in India. Now, if you do this odd even thing, a user with UID 7 in India has to wait for this load balancer, the server in US. It has to talk to server in US and get back the data, and that round trip is expensive, right? They have to wait that much. The user experience is bad. So then you will load balance according to region. Okay, now you are saying, okay, where is the user coming from? If the user is coming from US, okay, go to US, server is in US, so that person gets it fast. If the region is in India, they are saying, okay, let's send it to Indian server, right? Same with database, you can have all the thing going on there like that. uh, but so another interesting problem that I have seen people discussed is that, okay, so this is working, this is fine, you can scale like this. But with database, again, if you are saying, okay, it's an Instagram like application, and you will say, okay, all the popular people I'm putting in one this one Postgres database. With popular people, the problem is that they will have lots of reads happening, and if you put all the famous people in one database, then it will break easily, because everyone is going visiting, right? Many visitors are there compared to normal users, so it will break. So no, that's why system design is called both art and engineering. Like, it's an art. So the solution that you come up with, you know, uh, so that's why if you see big companies, every company makes you do system design. If you're going for like Amazon, all those, the Fang and all those things, because system design will help the recruiters understand your understanding of things, right? So there, the goal, interview goal, is not to come up with a perfect solution. That's not a perfect solution, right? Even there is no perfect solution anywhere. It's an art. You just understand the purpose and you just figure things out, and you study and you improve upon things. There is no one bullet solution for everything. So uh, this is a rough idea. And again, so another interesting thing I learned, so this is system design when you're building a normal application, okay, web application. The moment you go into machine learning and the system design in machine learning, like how you, so the flow will be like, I am now staying with my friend, and there is a college nearby, and there are MBA students. So they comes to me for advice and everything. So what they are doing is, they have a MBA with business business analytics. So they are learning data science, this machine learning thing, everything, regression, linear regression, all those sort of things. So I had this conversation, and one of the uh, boy did that. He installed this Python and Anaconda inside his laptop. So I told that to another friend of mine, and he said, "Why do that? It can be done in Google Jupyter Notebook." But the problem is that you can do in Jupyter Notebook. Okay, if you have lots of data, you have to understand the data. Use a library like Pandas, and you have to understand the data. Then you will write all the statistical, all this machine learning stuff, algorithms that you have. You figure that out. You wrote the machine learning model. You build the model. You train the model. Everything is set now. But that is living in Jupyter Notebook, right? That's great when the data scientist is working. But the moment you have to deploy that machine learning model to the world, right? There again, there's system design involved. And but that system design thinking will is completely opposite of what we discussed here. We are talking about caching things, we are talking about splitting things, all those things going on. But that machine learning system design works in a different different realm. So yeah, so I would say everyone should get some idea of system design, because this will help you. So like I said, front end, again, this will be split into different servers and different locations. CDN will be added so that it can load fast. So this is a rough idea. And even when we say GCP, when we say AWS, same thing is what's happening. If you have this knowledge, no matter GCP, no matter Azure, you can you're like, okay, I need a load balancer. What load balancer is given by Azure. If I'm saying, okay, I need to put the database, I need a NoSQL database. Okay, Amazon has DynamoDB. Oh, I need to store the cover image of the book. Where can I do that? What is the efficient way? Okay, so there is something called S3, Amazon S3. So I can store the static things there. Okay, I have built the website in React. How to deploy that? I don't need a VPS, or I don't need, like a huge front, server going on. I can store this in S3 itself if I want to. That will give the CDN and everything. And if I need extra CDN, I can do that. So this is the thinking. This is how it works. Then once you get this understanding, you can start seeing, getting like full picture. So what I would suggest is that once you get the basics, like what is server, what is a database, all this load balance, all these things, then you think about systems, right? Book my show. What is happening with book my show? How is it working? What happens if you have selected a seat in the book my show? How they ensure that, and the time you selected the seat, okay, 4 and 5 you selected. Now you have to make payment. You make payment, it will go to payment gateway, it has to come back, it has to confirm. So time is taken there, maybe 1 minute. But in that 1 minute, what if some other user books your seat? How that is done? How that locking happens, right? So that's where. So the moment you start thinking that, you take pieces from thing there again. If you think about that, then you have to know acid, which database they are using, what is happening, right? Uh, Booking, adding Instagram, uploading a picture, uploading a video, what is happening? How TikTok is able to upload the videos efficiently? How they are loading it fast? Load time is low. What did YouTube did to reduce the load time, right? So this is where you become an engineer, and it's very interesting journey if you dive into it. Very interesting, and will shape you as an engineer for like everything. So again, we can take AMD itself. Like there are the card system. The card system, when we were building, we are like, okay, there will be two, three things. Okay, and we can load from the database, Firestore, everything is done. But you know, that's not how I would have engineered if we were like we were picking like every piece. Okay, this is a card system. How the card system can be managed, right? There it goes another level of thinking. Like, okay, maybe there has to be a cache, or there has to be this that. So you become more user focused the more moment you become more system focused, which is like a paradox, but that's what happens. So yeah, that's it. Any doubts, any questions, any points? Hello. Yes. Yes, I'm yeah, you're audible. Hmm. Hmm. So there is expiry, yeah. So inside that, when you're using sessions, but which is not advisable, like sessions are not that secure. So there are other mechanisms to do that. But yeah, so when you have a session, you have this, UID going on here. Then you have the expiry of that session. Okay. So when it calls the with the UID, and it's like, okay, expiry is expired, then we delete that sessions, right? So basically, whatever we used to do in server, we are just outsourcing it to Redis. That's it. But the concept is same thing. If it's expired, then we will delete it. Which will add. That's a problem. The moment you say, okay, I want Redis, I want to give sessions in Redis, then you have to do, okay, how to manage that, how to delete that, when to delete that, how to update that, right? All those major parts comes. So yeah, that's it. That. Hmm. Yes, correct. Yeah, a lot of copy. Yeah. redundancy. Yes, correct. So you will need more servers. You will need more servers to handle this. Then there are concepts like sharding and all, which dives into deeper into that. So you will equipment wise it will be more, because you are like, okay, instead of one server you are going for like one server here, two second server, third server, fourth server, right? Server rack you have three, but the user experience is much better, right? Because user is able to get data fast. So if you imagine doing this in 2008 or 2007, okay, it was way too expensive. You have to get a server rack, okay. One server rack is here, you're getting another server rack, another server rack, another server rack. You have to put AC for the server rack, you have to do all the wiring, all the network, latency, everything. Many things matter. But now, because AWS came and changed the playing field, now all this can be done from your laptop. You don't need to buy a server rack. You are saying you will just spin up Postgres slave 1, 2, 3, and again you can say, okay, I need one in I need three in US, I need same three in India, right? And you're only paying for what you're using. There is no upfront investment, right? So that's what I read. Like there is an article saying that if you have a credit card and laptop, you're done. You can build any scale, system today because of AWS, which changed the game. Now there is GCP, there is Azure, and other companies out there, but it was AWS that did that, right? So all this spinning up of Redis, all this load balancing, everything is very easy now because of the AWS products they have added, AWS products they have added. Yes, yeah, okay, thank you. Okay, 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 correct, correct. Okay, so there is front end engineer, which you all know, who builds front end application. Then there is back end engineer, and backend engineer is the guy who builds the server in the sense the express application API. Okay, so the backend engineer is only concerned with writing APIs, and that's it. He only knows to write database APIs. But then there is a specialization called database engineer. So database engineer is the guy who designs the database, like from which database to choose, where to write the this index. Okay, where to, because when we are using Firestore, it's about one click. We just click create index, it will create index. But in the real world, like when outside Firestore, it's your engineering skills that will decide for this so and so use case. You need to design the database tables like so and so. You need so and so index so that it can be speed up. And again, like just the part of reading and this part, this is again choice that you make. So when we are writing a SQL query, we would write select all from that, but that select all in itself is too expensive. But a database engineer or good backend engineer who have learned that, dive deeper into database, will know that, okay, that's not how I should write, and the mechanisms of that. But backend engineer can be database engineer also if they have put in the time, and that they will do this all this part, the query about, okay, I am going to update this, so I want to first read for updation. So that knowledge backend developer can have if they dive deeper into that. But database engineering is visualization in itself about table design, database choice, all those hardcore things come into that. Then there is DevOps. So now backend engineer build the API, database engineer wrote all, the tables and everything. Now DevOps is a person who will like, okay, how to put this into the world, how to deploy it in such a way that it's all these mechanisms can work. Like backend developer wrote the API and updated the code. Now that code has to testing, all those things has to happen, and it needs to get deployed everywhere, right? So that's when they're like, okay, oh, we had to replicate the server, so and so. So this is like very time consuming. If you had to log into your server shell, you have to type in npm install node server, all those installation of node. So that's where Docker comes in, right? So Docker just enables you to do this very easily. Same with Postgres. If you want to spin up a Postgres database, you will have DevOps, Docker. So again, backend engineer might just write the API and like, okay, I have written the API, but DevOps will be like, okay, you need to use Docker, or you need so and so. We will connect the GitHub to so and so CI/CD pipelines so that ultimately it will get deployed. So yeah, then there is DevOps there. Also, like DevOps, you can say cloud engineer also. Similar thing, same thing, because cloud engineer is basically they know like what service to use from Azure, what service to use from AWS. They are well versed with that. So yeah, and so basically when we use the term full stack engineer, we are saying that person knows front end and back end. That's it. These are other specializations that goes deeper. Yes. But yeah, so they incrementally changed because they were the first Uber, they were the first Facebook, right? There was no companies operating in that scale at that time. So they had to learn on the go. Right. They built Twitter and Ruby on Rails because it was like a fun project, or I will just build this application. YouTube, same thing. Then only it became huge and big corporates, and then they had to think about it. Uh, Basically, any project should start with system design. Okay, so that's where like, okay, what is the size of the users we are talking about? Can a database handle that? One database, can it handle that? So the way this will be decided is initial, so this usage of Docker and everything, like this will be decided first itself, because we have this picture initially. Now, because we have Dockerized the database, we have using AWS. What will happen is that if it's like it can only handle like 3 million people, and beyond 3 million it goes, it will scale automatically. That's where Kubernetes comes in, right? If the capacity increases, Kubernetes will spin up another container and we have everything working smoothly. So when we are building it, we should always start with what is the user, what kind of data we are talking about, where does the data go, right? Because imagine we build this like this with Postgres, we built a server, this system we built after 1 year, maybe after 1 year, because the marketing team did good, some campaign got viral, all users started coming in. We don't have time to do all this. We can't do that. It will, everything will crash, bad press, everything will happen, all those negative press, publicity will happen. So there we can't, it's too expensive to effort wise and everything, it's very expensive to decide, okay, Uber can do that because they have such large number of engineers and money. But for a startup, it is too difficult to move away from this and say, okay, I will use this in MongoDB. I will put data in Postgres, and I will do sharding. All this, that's very difficult. For that, if there's a pipeline built from the start, then it is easier. You just have to spin things up. Okay, we have okay. Suddenly there are users coming from the Malaysia. You just have to put a a spin a server in Malaysia. That's it. You don't have to do any coding or anything for that. So always you should start about the data. What type of data we are talking about? What is the best database that could be handled for that particular data? Again, it matters on the team. Normally, when a startup is started like 2 3 people, they are like whatever they know. Again, Twitter used Ruby on Rails because the founder knows only Ruby on Rails at that time, right? Most even Indian companies, if you take most of the startups that are even popular unicorns, are using tech stack because the founder, the 2 3 people knows that stack. That's it. So yeah, but when we are building for the clients, and when we are building a product based product like a service, then we have to it's better to go through the system design step first, so that we know what resources we need, what is a developer capacity, team capacity, all that can be discussed. Yes, because with that you can also decide like overall, even the pricing of the project, like how much time it would time and the cost, right? So if you are saying it will have lots of, it's a video based application, you will have lots of video files, right? Where would you put that? So we can, like, we can put in Postgres, but that will be much expensive than we are saying, okay, let's use S3 and we'll put all the video files in S3. So that costing also, will somehow will get integrated to the system. And again, like proper people, computer science people, and when they do proper system design, they will start with numbers. uh so this so and so users will be there, so and so will, so that's how they design. But yeah, basically the idea is that once you build the system, it should scale. No matter how many users come, it should scale, and it should not break when something happens. So every time we see that with the Flipkart Big Billion Day, Amazon, their their respective thing of Big Billion Day, we see site going down, we see Instagram going down. All those is because of that. So that will be there, but the goal is to minimize that number of time it crashing. Okay. Anything else? Diljit Ashok. Okay. First. Yes, yes. Correct. 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 Hmm. First of all, no Firestore, SQL, SQL, because it is a very analytics based application. If you see at the core, because that's why. So when we were talking initially, the wordings we were saying that there is RSM. RSM has to, the user just has to add a product to the cart, order the product, done. Right. This was the briefing we were having, discussion we were having. So we designed the whole application based on that, and for that, Firestore is fine. Okay, you just have some user, you have some product data, and there is some request happening, done. But the moment you are like, okay, I need analytics, I want to know for of this product how many quantities has been ordered, I want to know this RSM, how much they are ordering. All this, when this computation happens, calculation happens. For that, SQL, SQL is the best, and it's from the history. It's like that, because it was built for that, right? Fire, correct. So that's it. That's it. Yes. No, the thing is that all these databases were built for different purposes. Okay, so when Firestore was built or NoSQL databases were built, the focus was not of computation analytics. SQL was there for that. There are many SQL databases was there. So SQL was doing this relational. Okay, so I will tell. Listen. So SQL came because we needed to store data which has a relation we need to compute. Okay, so so if you see, okay, so orders, there are orders table which will hold the user product, this much quantity has been ordered. Then I want to ask the database. Okay, so if you see, my sir, like earlier we were using Excel, right? Excel sheet was the main thing. So Excel will have all this data, right? So this user ordered this much quantity, this so and so. This was the story back then. Then SQL came. SQL came and said, forget Excel. With us, you just write a SQL query, you will get the answer. For this user, how many of this t-shirt has been ordered? SQL will spit that answer quickly. Excel, you have to go through and, like, why do that? Okay, so that's what SQL came. That was the purpose for which SQL was built. This querying part, and for that query has to happen efficiently, there has to be relation going on. So that's the relation database was built. Now that part was going very well. Okay, SQL was there, everything, many database came, MySQL came, Postgres came, everything is very good. Then there were lots of startups and other things coming up, and they are like, okay, we don't have, with SQL we need schema, we need to have the whole picture, we need all the tables written down, all this migration and all. We don't want to go. We want to build something like Twitter or something, which just has user data. I just want to, the user data can change, right? The fields can change as we build, because I'm just building it out. I don't know the fields that you'll need. So SQL is too cumbersome. I don't want to use SQL. What alternative is there? So that's when the NoSQL was born. Right? We need to store data, but we don't have a straightforward schema out there as of now. The schema will change as we develop. So we need a database which can hold, data in a different way. So that's how the NoSQL was born. So Firestore is a NoSQL database. So there are use cases for that. Any data that you want to just put there, no much computation, that is Firestore. But you can use, but it's not efficient. Yeah. So yeah, so that's a huge problem, because with we have all the calculation is happening in the code, right? Everything is happening in the code. We have to loop through and do increment, that stuff. That's what happening now. Data is called from the Firestore. We have to loop through or every order, do plus plus plus, add the quantity and the quantity. We have to come with the sum. But with SQL, you ask, calculate this, tell me the quantity. Okay, you are just saying, you answer me the quantity. A SQL will give you the quantity. You don't need to do any looping or anything. So it's fast, right? And no mistake of calculation and such. And again, like race condition, all those things, sorted out there. Like, you don't, double entry will not be there with SQL. So with, like, how important is that? How much of a problem is for a two RSMs to like add the same product to the cart? Is there a major problem? If there is not, there is fine. But if it's there, then you have to design the system accordingly. That database choice will be made accordingly. Yes, that's it. Okay, thank you. Okay, because Ashok, will you anything else, guys? Okay, that is it. Yeah, so I would suggest everyone to just pick any application that you are using. Okay, make my trip, book my show, whatever you are using. Basically, at the end of the day, you need three parts: server, the backend, that's a server. You need a front end, which can be client Flutter, it could be Flutter, it could be Angular, it could be React, whatever you want, HTML, CSS. So that's front end. Then you need a database. These are three things you need to start building any application, make my trip, whatever you want. But the moment you think about the data being stored, the number of users coming to your site, everything changes. Right? So you do some exercise on your own. Take open your mobile application and pick any, and you can understand how the usage is happening. Right? So you understand the users, how the user will be using your application. Okay, this is like I said, right? If it's not TikTok, it's fine. There is no writes happening. With this kind of book application, it's like only reading is again reading also less only. It's not too much. So just exercise your mind on that. Also, there are many tutorials, not tutorials. There are mock interviews. Okay, when I say mock interviews, I'm talking about system. These design people from Google, Facebook, people coming and answering as if they are doing in real life. So those videos are very helpful. Spend time in that. You will not understand many things. You will not understand what is a load balancer. You will not understand what is a reverse proxy. You will understand Postgres. It's fine. You don't need to understand. Once you understand, you hear these terms. Eventually, you will have the interest and curiosity to go deeper and understand. Like I read Netflix case studies. I don't understand anything. There are many things that they talk about. I don't understand because it will trigger me to think in a different scale, which I have not reached that point now. So yeah, yes. Hi sir. What next? Okay. Okay.